Okay, fine. Now we will solve. So now we will go to the example problem 2 in the exercise, that two resistance of 25 ohms and 50 ohms are connected in series across a DC voltage supply. Okay. If the voltage drop across 25 ohms resistor being 100 volts, find the total resistance and current drawn by the supply and total supply voltage. So this is our question. So we have to understand the question, and then we have to draw the circuit diagram, and we have to write the given data, and then we have to write what to be solved, and we will see how it should be solved. Okay. So now here I am taking the two resistors connected in series. Okay, here already a series circuit has been drawn. Okay, now what is the values given in this circuit are, first one, this is 25 volts, 25 ohms. Okay, and this is 50 ohms. And here, if the voltage drop across 25 resistors is 100 volts. So what this line is telling, if the drop across 25 ohms is 100 volts, that means V1 is equals to 100 volts. Okay, V1 is equals to 100 volts. Now we have to find out the total resistance. RT is equals to how much? Okay, and then the current drawn from the supply. So what is the total current? I is equals to how much? Okay, and the total supply voltage, that V is equals to how much? Okay. Hmm. So here this is a circuit diagram, and what is the given data we have to write. Okay, given data is, what is the given data? We know R1 is equals to 25 ohms, and R2 is equals to 50 ohms, and also we know that V1 value. V1 is equals to 100 volts. Okay. Now what we have to find out? We have to find out total resistance and total current and the supply voltage. Okay. So this is a series circuit. From the series circuit, as it is a series circuit, I know the total resistance R is equals to R1 plus R2. Okay. So which I can directly find out, this is 25 plus 50, which is equals to 75. Okay. Okay, so we know that it is 25 plus 50 is 75. Okay, so it is a 75 ohms. So now we got R value. Okay, R is 75. Okay, fine, 75 ohms. Let it be like this. Okay, now we got. Now we have to find out the I value. So for finding out I value, uh, here in this area, I know 25 ohms. R value, I know 100 volts. V1 value, R1 value. So I can find out I1 value according to Ohm's law. So according to Ohm's law, that I1 is equals to V1 by R1. Okay. So directly I'm substituting that value. V1 here it is 100 volts divided by R1 is 25. Okay. So which is equals to 4 amps. Okay. So here 100 divided by 25 is equals to 4. Okay. So you got 4 amps. So in series connection, you people know that total current I is equals to I1 which is equals to I2. Okay, so all the branch currents will be equal to the total current. So the total current is here is 4 amps. So you found even I value. Okay, so now you got I1 and also R. Now you have to find out total V value. Okay, so you people know the current which is flowing through the resistor 2 also, that is I2. Now I2 is 4 amps. So you people know I2 value and R2 value. You can find out V2 value. Okay, because there is only one unknown value. So how you will find out? So here V2 is equals to I2 into R2. Okay, which is equals to, now I2 is 4 amps into, sorry, 4 into R2 is 50. So what is 4 into 50 is 200. Okay, so 200 volts. So here 4 into 50 is 200 volts. So now you people got V2 value. Okay, so now V2 is 400. But we have to find out total voltage value, not the branch voltage. So how to find out total voltage value? What is the formula in series? Total voltage is equals to V1 plus V2. Okay. So you people know V1 value. V1 value is 100 volts and V2 value is 200 volts. So the total voltage value is 300 volts. Okay. So now you have got even the total voltage value. So now you found total resistance, total current and total voltage value. So this is how you have to calculate. You have to find the values. First you have to understand the question. Then you can directly solve the answer. Okay. Now we will go to the parallel circuit problem. So here we will see the example one. Calculate the effective resistance when two resistance of 20 ohms, 25 ohms and 50 ohms are connected in parallel. Okay. So before going to any problems, you have to understand, you have to analyze the problem first question and you have to draw the circuit which will be easy for you people. Okay. So we will draw the circuit first. So we have to draw the parallel circuit. So here they told that there is a three series resistors connected in, sorry, there are three resistors connected in parallel. Okay. So this is a parallel connection. So this is R1. So R1 value is 20 ohms. So R3 is 50 ohms. Okay. First, you have to draw a circuit diagram and you have to represent all the given data in the circuit diagram. This circuit diagram will be easy for you people to analyze. Okay, so this is a total current I, and the current which is flowing through the R1 resistor is I1, and the current which is flowing through the R2 resistor will be I2, and the current which is flowing through the R3 resistor will be I3. But here they have not asked any question regarding the currents. Okay, they directly asked the question that the total resistance. Okay, so the total resistance formula we know that that is 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, directly substitute the values. R1 is 20, R2 is 25, and R3 is 50. Okay, which will give you 0.05 plus 0.04 plus 0.02, which is equals to 0.11. So 1 by R, total R is equals to 0.11. So actually what is the total resistance? So total resistance is 1 by 0.11, which is equals to 9.0909 ohms. Okay, so this is a total resistance. This is a total resistance. Okay, here one more thing I would like to tell you. uh, Here how to, I mean, self analyzing of whether this answer is correct or not. Okay, see, when you calculate any resistors in parallel, here we are calculating three resistors which are connected in parallel, the total resistance value will be always less than the smallest value. Remember this point. The total resistance value will be always lesser than the smallest value. Okay, here the 20 ohms, 25 ohms, and 50 ohms. The smallest value is 20 ohms. So your resultant resistance must be less than the 20 ohms. Okay, so here it is 9.099. So this is how, once if you get any doubt whether your answer is correct or not, so this is one of the checkpoint where you can check it. Okay, yes, you got a less than 20 only, so this might be right. Okay, so this is a total resistance calculation formula. Okay, fine. So now we will see an exercise problem that here three resistors of values 4 ohms, 6 ohms, and 8 ohms respectively are connected in parallel to a supply voltage of 24 volts, and calculate the current in each resistor and the total current and effective resistance. Okay, see, effective resistance means the total resistance value. So now we have to, so first we have to write the given data, and also you have to draw the circuit. Okay, so first we will draw the circuit. So the three resistors are connected in parallel and connected to a supply voltage of 24 volts. Okay, so this is 24 volts, and this is R1. The value is 4 ohms. Okay, and this is R2. The value is 6 ohms, and this is R3. The value is 8 ohms. Okay, this is a total current I, and there is a branch currents in between, that is I1, I2, and I3. Okay, there will be the branch voltages also V1, V2, V3. As it is a parallel connection, all the voltages will be equal. Okay. So this is our resistor circuit. So what we have to calculate? So given data we will write first. Given data is R1 is equals to 4 ohms and R2 is equals to 6 ohms and R3 is equals to 8 ohms. Okay. And the total voltage also given. This total voltage is equals to 24 volts. Okay. Now we have to find out what is total current and what is individual currents also. I2 is equals to what and I3 is equals to what. Okay. So total current and also we have to find out the total resistance. Okay. So first we'll find out the total resistance which is equals to, there are three resistors, or otherwise you can calculate 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is a formula. So here 1 by R1 means 1 by 4 ohms plus 1 by 6 ohms plus 1 by 8 ohms. Okay. So here we have to calculate with the calculator. Here 1 by 4 value is 0.25. Okay, 0.25 plus then 1 by 6 value 1 by, wait, okay, 1 by 6 value is 0.1667. Okay, plus now 1 by 8. So 1 divided by 8 value is 0.125. So we have to add all these values. 0.1125 plus 0.1667 plus 0.25, which is equals to 0.5417. So this is 1 by R value. Now we have to find out R value. So 1 divided by 0.5417 is equals to, so R value is 1.85 ohms. Okay, so R value is 1.85 ohms. So this is a total resistance. Okay, so here we got right 1.846. Okay, so that is only value, here we got 1.846. So directly you can write 1.846. Okay, so now we got R value. We have to find out So we got R value, total resistance value. So we know the total voltage now. We know the total resistance. We have to find out the total current. So the total current I is equals to V by R, which is equals to 24 divided by 1.8846. So 24 divided by 1.846 is equals to total current is 13.001 amp. Okay, so the total current value is not given here. So total current is 13.001 amp. Okay, so now we have to calculate the individual current. So how we can calculate the individual current? That I1. So we know that total V is equals to V1 is equals to V2 is equals to V3. Okay, which is equals to 24. So now we know V1, V2, V3 and we know R1, R2, R3. So we have to find out I1, I2, I3. So I1 is equals to V1 by R1. Okay, which is equals to 24 divided by R1 is R1 is 4. Okay, so 24 divided by 4 will give you I1 value. Okay, so this is a 6 amps. Okay, you have to find out this is I1 value, right? Likewise, you have to find out I2 value. So I2 is equals to V2 divided by R2, which is equals to 24 divided by 6. So 24 divided by 6 will give you 24 divided by 6 will give you 4 amps. And likewise, I3, which is equals to V3 divided by R3, which is equals to 24 divided by 24 divided by 8. Okay, so 24 divided by 8, which will give you the amp. Okay, so you found and your answers are correct if you check here. Okay, so you found I1, I2, I3 value and R value. So according to the formulas what we know in the parallel connection. Okay, so this is how you have to calculate for any problem. Okay, step by step. Okay, okay, so here this is a problem on series and parallel circuit. Okay, till now we have talked about only the series and only the parallel circuit separately. But this is a combination of series and parallel circuit. Okay, now this is a circuit which is given. Determine the current delivered by the source in a network. So here this is a network, a different complicated network. Here we have to find out the current which is flowing through this network, that we have to find out the total current which is passing here, which is coming from 30 volts. Okay, so before that we have to calculate what is the total resistance. If we know the total resistance, we already know the total voltage. If you know the total resistance, we can find out the total current. So we have to solve this network. So we have to simplify the network one by one and then we have to solve it. Okay. So here the network can be simplified by series and parallel reduction technique. If you observe 2 ohms and 2 ohms here. These 2 ohms and these 2 ohms are in series connection. Okay. This is represented in like a delta form, but it is series connection here. These two are in series connection. The current which flow from this branch have to flow to even this branch also. So if the same current is flowing through the two branches, then these two branches are in series connection. Okay. So this 2 ohms plus 2 ohms is representing here 4 ohms. Like same, this 1 ohm and this 2 ohm also in series. So 2 plus 1, 3 ohms. Okay. So అదే విధంగా you cannot do this and this, okay, because the current which is passing through 1 ohm is not equal to the current which is passing through 2 ohms, because there is another diversion here. But here the current passing through this 2 ohms is equal to the current passing through this 1 ohm. Okay, so this is in series connection, this is in series connection. So this is 4 ohms and this is 3 ohms. Now you have to find, and if you observe, this 4 ohms and this 4 ohms are in parallel connection, and this 3 ohms and this 3 ohms are in parallel connection. So you have to do parallel problem, parallel solving. Okay, if you do parallel 4 and 4 in parallel connection, you will get 2 ohms. If you solve the resistance, you will get 2 ohms. Okay. Okay, so here 2 ohms and this 3 ohms and 3 ohms, you will get 1.5 ohms. Okay, so now if you observe these two, again these two are in series. So you have to solve these two, and this 2 ohms plus 1.5 ohms, you will get 3.5 ohms. So this is the 3.5 ohms value. Amma. Here value is not given. So this is 3.5 ohms. Now 3.5 ohms and 2 ohms will be parallel again. So 3.5 ohms and 2 ohms will be parallel. So this parallel value will be 1.27 ohms. Okay, now 1.27 ohm and 1 ohm again in series. So 1.27 and 1 will get to 2.27 value. So 2.27. So 2.27 and 2 both are in parallel. So these two parallel, you will get 1.06. Okay, after this is a final total resistance, equivalent resistance, resultant resistance. Okay, so you got the total resistance is 1.06. Now you can calculate the current. So what is the current? I is equals to V by R, that is 30 divided by 1.06. So I is equals to 28.3